This is our 18th annual Student Research Symposium. What we have is posters explaining research from all the departments in the college, biology, chemistry, computer science, mathematics, and physics and astronomy.
And this is a chance for students to not only gain professional development in their research, but also to interact with other students that are doing research across the college. We have an incredible diversity of projects that are going on, and many of our students are going to go into fields where they're going to interact with professionals from other areas. And this allows them that opportunity to see what other research is going on and gain that level of professional development they wouldn't get at a lot of other universities. So it's a great opportunity for them.
Hi, I'm Xiaowei Hu, and I'm from the Department of Math. And this time I'm working with Dr. Laney about the optimization analysis of waiting time and the resource utilization. So the motivation that why we want to do this project, because this study is like a case study. Okay, we are working for the UAMS OBGYN clinic, and we want to analyze how long will a patient wait for a doctor, and what is the resource utilization of like the different nurses and different doctors like that. So that's the topic of my project.
My name is Aaron Crawford. I am in the computer science department doing research with Dr. Sheng. Our research here is finding results from large amounts of data, even if it's low quality or multiple from one source. The big difference here that is applied is most sources have only one result, which are used to classify things, and what we're trying to do here is look for things that have multiple results, which in this case is movie ratings, which could be used for a large array of things, such as custom tailoring things to customers, or deciding what is actually good or not in a movie rating like this. The difference here that we're looking for is actually being able to do that in a low-cost situation. So it has a lot of business applications where you might be able to make the choice to go with a lot of non-professional results to get meaningful data, as opposed to paying for professional services to get things done. So that's pretty much it in a nutshell for what we've done for this section.
Hi, I'm Lauren Stearman. I'm a graduate student here at the University of Central Arkansas, and I study fish. I studied a little fish called the redfin darter. And this is a great example of this situation. This fish is found throughout Central Arkansas, up into Oklahoma, and a little bit of Kansas and Missouri. It is not widely distributed. We have studied this fish taxonomically to try to understand it as far as what it's related to for about the past 100 years intensively, but we know very little about its biology. Now, we have a new disturbance in this area, natural gas extraction. We have lots of construction that goes on with that, which leads to lots of siltation. And we assume, as a darter, what we should see is that the adults, the population as a whole, should respond. That's the standard approach. However, what I'm proposing is that's not necessarily the case. And in fact, what we could see is if we look at a metric of abundance, relative abundance, versus a metric of natural gas drilling, we can actually see that the adults are not declining in either case. There's really no pattern. So, is this a situation where they're not sensitive to this disturbance? Or is this something we don't understand their biology well enough?
This advertises our student research program to other students, gets more students involved. It's grown every year, and I think that this is probably the last year we can hold it here. I think we'll have to go to the Student Center Ballroom next year because the program has grown so large. But it's one of our key events of the year for showing what our students can do.